In this class, we will talk about inheritance in Python. Inheritance is a concept of object-oriented programming that is called OOPS in Python. So first, let me write OOPS. Okay, the full form is object-oriented programming. So programming that is done with the help of classes and objects. Classes and objects and its properties related to classes and objects are called as it's called as object oriented programming. So before that we were learning about loops for loop, while loop. We were learning about definition, that is function, right? We were learning about if else, everything we were writing it sequentially. So that was sequential programming. But now this is not sequential anymore. This everything is about classes, objects and their properties. So this programming is called object oriented programming. So we will, in this course, we will not cover all object oriented because it is very big. It is a subject by itself only. So we will just understand few attributes that is useful to us in this course. And in this class, we will talk about one of those properties that is called inheritance. We will talk about, and as mentioned previously, everything about programming is taken from the real world. Every example, even if the use case, we have first developer first saw the real world, that how humans operate, how things operate, then they create those things into coding. Okay, so first let's get to the definition of inheritance. Inheritance allows a class to inherit attributes and methods from another class. We will talk about it. These are new two terms, but you already know the meaning of it, but not in the context of oops. Okay, so I will get to attributes and methods. Let me write it down so that I will explain attributes and methods. Attributes, methods. Promoting code reuse. Again, code reuse. We used function for code reuse. We used classes to kind of create multiple instance of the class, just like we did in the previous video. That is, we are creating multiple instance of car, Maruti Suzuki, Maruti Desire, and different Kia Seltos we have mentioned, right? So we have used the same code to create multiple instances of the same of different cars, okay? And creating a hierarchy of classes. To support hierarchy, we will talk about hierarchy here, but first let's understand this part. Child classes inherit properties from parent classes. This is about coding. Now let's see this example in real world also. Inherits. Child has parent A and parent B, right? So child inherits some of the properties from parent A and some of the properties from parent B, right? So child inherits properties from parents. Like the same thing, inheritance is, we have class A, we have class B, and we have class C. So class B has property, suppose 1 and 2. Okay. Class B has property of 3 and 4. Class C has property of 5 and 6. Now this class A is only limited to 1 and 2. But I want more properties. Now suppose I want more properties. So instead of writing more code like 3 and 4, we will just use the code itself because the code is already present in class B. So we will inherit class B properties, so we can use 3 and 4 in our code as well. We are not writing the code. We are just using the code because we are inheriting the property of class B, just like we inherit properties from our parents. Understand? We are not creating properties of our own. We are inheriting properties from our parents. The same thing we can do in classes and objects. Okay, let's see the example. We have two classes here. The first class is doctor. What is the name of this class? The class is doctor. What is the first function we are creating? We are creating the special function which is used to initialize the variable def underscore underscore init, and we are passing name and specialization, and we are checking self dot name and self dot specialization we are using. So this class is for doctor. It is storing doctor name and its specialization. Okay. Now the next class is surgeon. Next class is surgeon. So surgeon class is having property of expertise. This surgeon is expertise in which part? So what we want now, this surgeon class is only having variable expertise, but we also want name and specialization for the surgeon. Name and specialization for the surgeon also, which is not present in this class. So what we will do, we will just inherit doctor class. This is doctor class. If I just mention doctor class in surgeon, I can access doctor class attributes. What are attributes and methods? Let me first define it. In normal Python, when we write a equals to 2, a is called variable. When I write in normal Python, when I write def equals to add, this is called as function. It is a function for addition, variable and function. But this is normal Python, not for object oriented programming. When we write any variable inside a class, it is called attribute. That's it. Variable inside a class is called attributes, and function inside a class is called method. Just a different name with the same naming convention, with the same working. Okay, working is exactly the same as the normal. Variable is same as attribute, function is same as method. But when we are writing function inside a class, it is called as method. When we write variable inside a class, it is called attribute. So this init is a special method. Init is not a function. If we talk about naming convention, init is called method. Self.name, specialization is called attributes. Understand? So in this class, I only have expertise, but I want doctor attributes also. Doctor class has name and specialization. So what I'm doing, the first is self. I'm passing name, specialization, and expertise. Okay. Name, specialization, and expertise, and I'm passing super. Okay. When I use super, super means super will super points out to this class reference. Okay. I know it is a bit confusing, but when I'm writing super, it means I'm denoting something which I'm inheriting. Okay. Let me write it down. No need to understand its detail because there are a lot of things to be covered in the classes and objects, but we are only going to touch the basics. If this is class A and there is code of class A, this is class B, and I want to inherit all of the class A properties, what I will do, I will just write A. But A also has init function, right? Every class has init function. And I told you, whenever we create object of class A, the first function that will run is init. Now I'm inheriting A. B also has some init. B is already having init. Okay, B is already having init because every class should have init, right? A class is having init, B class is having init, but B class is inheriting A also. So who will initialize A class init? Okay. So I will write super keyword. This is called super. So when I write super, Python will automatically point out to inherited class. So super means class A object. Okay. Then I'm going to write super dot, it means A dot underscore underscore init. Then I will initialize its variable. What are the variables of surgeon? Surgeon is having name and specialization. So see what I'm doing. Super means the class we are inheriting. What class we are inheriting? We are inheriting doctor. Doctor dot init means doctor dot init. Dot is a special uh, symbol, you can say, to access anything, access class attributes or methods. Okay, so what is super? Super is doctor. How to access attributes and methods? Via dot. With dot I am accessing its function, special function. Is it present? Yes, init is present, so I am able to access it. What is the argument init requires? Init requires name and specialization. Do we have name and specialization? Yes. Surgeon class init has name, specialization and expertise. So we are just passing it. So this class self.name and self.specialization is being initialized. So self.expertise is the expert is passing. So this is two class. Okay. Now because I want surgeon class to have doctor, there is no point of creating object of doctor, because surgeon class has doctor as well as surgeon. So see what I'm doing here. I'm creating object of surgeon and initializing with value name, specialization and expertise. I'm passing three value: doctor name, doctor specialization and doctor expertise. So this is the first function. When I'm creating the object, the first function that will run is init. So in its init, I will catch this value name, specialization, expertise, which I'm passing here, right? What is the next line? Super dot init. Super means doctor. Doctor init is taking two names, name and specialization. Do we have this? Yes. We have name and specialization because we are passing in surgeon. Name and specialization will come here. Self dot name will be Dr. Smith. Self dot specialization will be general. Okay. Self dot specialization will be general. Then everything is done. Then it will come to self dot expertise. Self dot expertise is expertise. So see, surgeon class is only having one variable, self dot expertise. But because surgeon class is inheriting doctor, it has access to these two attributes as well. That is name and specialization. So see, this surgeon class, I've initialized the object and this is the object. So surgeon class object, I'm writing specialization. So object of surgeon class is able to access self dot specialization. Can you see? Surgeon 1 dot specialization is printing general. Surgeon 1 is an object of surgeon class. This is surgeon class. Does surgeon class have self dot specialization? No, it does not have. But doctor class has. So I'm inheriting doctor class, initializing doctor class, so I can have surgeon dot specialization. Understand? So this is doctor class. So this is for initialization. If I don't want to initialize, I don't have to write it. Okay. So let me give you a different example. This seems a bit complex because we have this new variables. Okay. Let's create a simple class of calculator only. Okay. Let's create class, this is calculator 1, and itself is doing nothing. This has another function called add, and it takes two or three arguments. First is self, that is by default, and it will take number 1 comma number 2. What it does, it adds into it adds this number 1 plus number 2 and return C. Okay, or just let's print it, we don't want to return it. Print C. This is calculator 1. It has init function and it has add function. Okay, now let me create another class with a different name. The name will be calculator 2. This one will have subtract. It will do the subtraction. Okay, and it will print the subtraction. So now I have two different classes. One is having facility to add it, one is having facility to subtract it. Okay, but what I want is calculator 2 to have properties of calculator 1. So what I will do, I will inherit calculator 1. How will I inherit? I will just write calculator 1. See, in this one, I've made the init function useless. I don't want to initialize anything. I just want to do calculation. I don't want any global variables. Okay. I just want to use the function. That's it. So calculator 2 is having properties of calculator 1 as well. Init function is not useful, so we will not use super and other keyword. We can directly use add. So now I have calculator 1 and calculator 2. I am running it. In the next line, let's create object. We will create object of calculator 1 or calculator 2. We will create the object of calculator 2 only, because 2 is having attributes, 2 is having methods of calculator 2 as well as methods of calculator 1 as well. That means 2 is having function of calculator 1 as well as functions of calculator 2 as well. Okay, both 2 and well. So how to write it? Calculator 2. Do we have anything in the init argument? No. Self is by default. Excluding self, do we have any others? No. So no need to mention, no need to send anything. So I'm creating object. I'm just writing it as object 1. Okay, this is just a temporary one. So object 1 will have properties of calculator 2 and calculator 1. Okay, what I want to do now, I want to pass object 1 dot add of 1 comma 2, object 1 dot subtract of 1 comma 2. Let's forget about this one. Okay, let's forget about this one. Let's just see this one. This 3 lines of code, we don't know. Suppose we don't know what is the code behind it. We only know add and subtract. We only know add and subtract. This class, this object is having properties of add and subtract. Let's run it. No issues. Calculator 2 was initially having subtract property only, subtract method only. But because we have inherited calculator 1 also, we are having proper method of add also in our bucket. So this object calculator 2 is the object, this object 1 is of type calculator 2, right? It is of type calculator 2 class. But because calculator 2 class is inheriting property of calculator 1, this object 1 of calculator 2 is able to access add as well as subtract both of them. Understand? So this is called inheritance. This calculator 2 class is able to inherit function add of a different class, that is calculator 1 class. So this super and init is kind of a little complex one, but it is the same thing. Okay, it is just the same thing, that inheriting the property is the main goal that we are going to learn here. Okay, that's what we are doing here, add and subtract. So we can do the same. We can create different cars, like we can create car German, car Indian. We can inherit some of the German car properties. We can create some of the Swedish car properties and then create a new car, something like that. Okay, that is inheriting. This is a very powerful concept. Classes, if suppose someone has already created all the add, subtract, division and multiplication, right, and we are creating a new class, but we don't want to create this function because it is already present. What we will do, we will just inherit that class and use the property. Understand? That is inheritance. The use case in healthcare system, inheritance is essential for creating a specialized class like surgeon that can inherit common attributes of a general class. See, the same thing. A class like surgeon is inheriting common attributes of a general class like doctor. Okay, this promotes code organization, reduce redundancy. We are not using add again in calculator 2. We are directly inheriting the property of calculator 1. We can create a new function of addition in calculator 2 also. But why to create it? We know that class calculator 1 is having add, so why not use it? So we are reducing the redundancy. We are allowing for easy execution of functionality, easy extension. We are extending the properties of this class by inheriting another class property. The importance lies in creating a clear hierarchy of classes reflecting the real world relationship between healthcare professionals, right? So if professional A, the same thing. If Dr. A and this is Dr. B, if Dr. A knows XYZ and Dr. B know ABC, we can inherit properties from Dr. B to Dr. A. Not, I mean, not technically this is possible, but we can kind of do the knowledge transfer that this Dr. B knows ABC. Why not learn it, right? Why to do the research by ourselves when we can learn from our different specialized doctor? We can learn the attributes from them. So that is called inheritance in healthcare. Okay, this is just about knowledge, but in the coding also, if Dr. B has a kind of book or notes for notes kept in a separate place, Dr. A can take it and can read the specialization all by himself, right? So that is inheritance, and we will use inheritance a lot in coding. That's why because there are a lot of different topics in OOPS, that is object oriented programming, and I've only kept inheritance, encapsulation and few others in the course. Okay, so don't worry about this one if you don't understand, but I've tried to mention it super and in it. If it makes sense, then just read it and implement it. Otherwise, this is a very good example, a very simple one, that subtract and add of different class we are using in a single class object. This is object. So one object is having multiple properties now. That is called inheritance. So in this class, we have talked about inheritance in object oriented programming. See you in the next OOPS concept. Thank you.